So lab 9, what we're going to be doing is we're going to do something really cool actually. That's We're going to be taking data from a CSV file, and hopefully we're all familiar with what a CSV file is. If you're not, it's just a file of raw data. So imagine a table, but instead of cells, every little value is separated by a comma. So you know you just have your rows of data. Each line is a row, and each column is separated by a comma. And we're going to use comma separated values, and they're all called CSVs. But a lot of times they're uh, they're separated by other things. Because imagine if you had first and last name all together in one column, separated with a comma, or someone just happens to type a comma into a name or something. um, Obviously that's going to throw off all of that's going to throw off that row. So you can do different things to avoid that, and I'll let you research that. But just for right now, know that it's our data file, and you can actually pull up the data file we're going to be looking at. So let's real quick, let's go into our files here. Data CIT225. Actually, this one's in a little different spot. So you're actually going to come over here to root, and then there should be this folder down here called U01, app, Oracle, and then upload. And this is where our CSV files are that we're going to be working with. And specifically, we're going to be working with this transaction upload2.csv file. So if I open this up, it'll open up in the built-in Excel software for our thing. It's not Excel, it's called Calligra. But we're going to do this, and we're going to say, okay, and we can say the first row contains headers or the first column, but it doesn't look like any of that's true. Because we could look at this, and if it had names, then we could do that. So let's just click OK, and then close out all this. Put you away. Make you bigger. Move you over there. Okay. So in here is our data, right? So just like you'd normally see, and this is transaction data. And we don't really know what this means just by looking at it, but in the instructions, it kind of talks quite a bit about, the columns and whatnot. So, but the important thing to note is that it's transaction data. And so what we're doing is we're simulating as if it were coming from a point of sale system, a POS system. And you can see how basically it's just a bunch of data in here. And we're going to import that into a table in our database so we can do stuff with it. And surprisingly, this is something that is probably one of the most frequent things that I do actually is do this kind of stuff. And in fact, it's got its own name. It's called ETL, which stands for extract, transform, and load, right? So ETL is basically a process of moving data from many sources into one warehouse, essentially, and is very popular in data warehousing. So like in my job, I do this with student information, and scoring data and all that kind of stuff, rostering. But it goes, and our data goes all over the place because we have, like, I don't want to say hundreds, but we have like probably 50 different pieces of software that various schools or the district uses to do testing and to do analytics, assessments and that sort of thing. And so basically those different systems hold their data in their own databases. Well, that data is useful in its own scope, but a lot of times we want to bring that all back together so we can compare it with all of our other data, which is really important. And so a big part of what I do is ETL workflows, by getting data out of the multiple databases. And a lot of times, we don't have access to their databases, but they'll give us CSV files that we can export. And so we have those CSVs come out, and we script it so that so the extract is the CSV file being downloaded. We put it on a server and then we transform it. And what it means by transforming is right in here, this ETL, we transform it by putting it in a format that works. So then we put it into our data warehouse in the format that we want. And, we make it so it's smart, just like what we're going to do here. Actually, we're going to make it so every time we do an upload, it's smart about it. It says, okay, did I already upload this row? And if I did, I'm just going to update information on it. Oh, but if this is a new record, I'm going to insert it. So it's pretty cool. That's called a merge. We'll get to it. It's one of the coolest things that you can do. You'll use it a lot. It's called a merge or an upsert. But essentially what we're going to do, the beginning of this lab, is we are preparing to start the workflow of ETL. In fact, we're doing kind of step one. Well, step one's kind of already done because we've already extracted, right? We have our CSV. But now what we need to do is we need to import it so then we can transform it. So because it's going to come out in this in whatever record the folder or the CSV file is. So, whatever these rows are, this is kind of what we have. So we're going to take it and import it into our database, and then we're going to transform it so that it works with our database. Because essentially what this is we have like the Potters and we have them renting movies, and stuff like that. Well, all those other people, they have some rentals, I believe, but we're gonna backdate a bunch of transactions. So it's all there. And by doing that, we are gonna put in a ton of rentals, a ton of rental items, and a ton of transaction. With transaction is going to be our new table that we're going to build. So that is our new seg. I'm going to discard those changes. We don't want to save them because we want to keep that file just like it is. So let's look at these instructions real quick because we had a nice little segue into the lab there. So step one is we're going to create this new transaction table and the sequence, and then we're going to put a unique key on it. So this is all pretty straightforward. There's only one new thing, and this is this natural key. So a natural key, and a natural key, I like to think of it as when we say a natural key, it happens naturally, or I like to think of it almost like business logic, like, oh, it's just natural that we would put that in a constraint on there, that unique index. So it says after you create this table, you need to add unique index on the following columns, then transaction table, and it says this is necessary to improve runtime performance on the merge operations later. It's actually not in this lab, it's in lab 10 and 11 is when we're going to do those. So you're going to put unique indexes on these, and it sounds a lot more complicated because it says natural key, just it's unique index, which we should have done those before. Number two, we insert the following into the transaction type rows and payment method type rows in a common lookup. So just like we did in, I believe it was lab 6, we've done it a couple of times now, I think. We did it for price type and rental item type. We're going to do the same thing, but we're going to add rows to support transaction type and payment method type. So those are just simple insert statements, and you have your various values here that you're going to use. Make sure that you get the lookup code for those ones because they are important. And then step three is kind of a new one. The nice thing is it's pretty easy as long as everything goes right, your data is good, because really it's almost all here. So step A is we create the airport table and the sequence for the airport table, which again is nothing new. So that should be pretty straightforward. We create a unique natural key in this table. And so just so you know, when you create a natural key, the reason why I say it's a natural, and this is a really good example, is because we want certain records to be unique. So per se, so my airport is SLC, Salt Lake City in Utah. That's the closest big one to me, one we usually use. So, But, we don't want a Salt Lake airport in twice, right? That's the point of the unique key. So how do we say that that's deterministic? Well, just like New York City actually has two airports. It's got. Does anyone know the two? I know JFK and anyway, there's two airports, right? And potentially a city could have two airports. So what do we need to do to make sure that it's unique, that we have unique
LaGuardia.
values? What was that? Do you know what was the name of the airport?
LaGuardia.
LaGuardia. Yep. Okay. So, so New York City is a great example. So, because let's say we had a unique uh, key, a unique constraint on the city and the state, right? Well, if we just did it on the city and the state, places like New York City could only have one airport. So, what we do is we say not only is it the state, province, the city, we also have an airport city, which again for New York City doesn't help at all, but the airport code then would. So then we could say, okay, in New York, in New York City, we have a JFK and whatever the code is for the other one. And so then we all of a sudden can have our uniqueness, but still allow for all of our constraints or our scenarios. So that's where this natural key comes in. So when you see a natural key, the way that I always like to think of it is like, okay, like let's think through this logically, because that's kind of to me what a natural key is it's a real life thing that makes something unique. So you know in that case, this is a pretty good example. I'm trying to think of another good one. Um, but here's another example. So, like, let's say we wanted to pretend that, like, let's say we put a unique natural key on first name, last name, middle name. We would have times that would break. Because obviously people are going to share names. Now, let's say we added birthday to that constraint. Well, that would make it a little bit better, but there's still those possibilities. And so, those get harder. But in this case, where we have a very deterministic rule set for airports, the airport codes are unique, then it works good. And the way that and I don't know if we've done this before, I think we have, but you can build constraints with multiple columns. And what that means is that it takes all three or all four. So in this case, it takes all four. So just like we talked about earlier, we could have New York twice for state province, no problems. We could have New York City twice for city, no problems. We could have, all those together for those two, no problem, because these two still have to be unique. So unless you duplicate all four of these columns across two rows, then it's going to be a problem. But that's why we build the constraint, is because there should never be two airports that have the same state, city, and code in our database, right? Specifically the code, but we will put them on all of them. So that's a natural key. So even up at step one where we built that natural key, um, we do it on these right here: the transaction account, payment account number, all those kind of things, because those are going to be what make those transactions unique. And it is logical. That's kind of why it's a natural key. All right. So, anyways, we build the airport table, we put the constraint on it, we make sure we have our sequence. And then this is kind of where we're going to kind of dive into some unknown territory just a little bit. You guys have already seen this a little bit, but this is kind of new again. So we need to seed the airport table with at least these cities and others that you've used to insert in a contact table. So you're going to write these insert statements. And the important thing, and there's already been some people working ahead that have come across this. The important thing when you do this is you want to make sure that if you have, for all the people in our database for contact and address, we want to make sure that these match. So for people in California, they need to match. And we're going to talk about that in a little bit, because you actually might have to update your states to be the full name written out. And let's actually look at that real quick. So if I do a select distinct state province from address, you'll notice that I get CA, the abbreviation, and then Utah. So what we're going to need to do is we're going to need to change all of our CAs to be California written out. And I believe that it talks about that somewhere. Right here. So we'll get to it, it looks like, in just a minute. So yeah, we'll get there. And you want to make sure that they're all matching this exactly. So if they're all uppercase here, then do it, make sure they all match good. Then we create the account list table and the account list S1 sequence. So we're just doing a lot of table building. So we build our table and sequence for account list. And then we get into the stuff that's kind of unknown territory. So we are going to run this, this code that he already has, because this is actually going to kind of do a lot of this for us. It's going to build our accounts. And just so you know, just like with before, so when we run this, so let's say I put this in and I run it, it'll say procedure created successfully or procedure created with compilation errors. Well, if it says that you created with compilation errors, type show errors. In fact, let's try it, because I don't have an account list table and I don't have an airport table in my database yet. So let's copy this and let's paste this in here, because we are going to get an error. And you'll notice it says, just like I said, procedure created with compilation errors. If I type show errors, then we can see what's going on, because his code that's on the website is accurate. So we know it's something that we did previously. So like in this case, table or view does not exist. Table or view does not exist. I can go back up and look, on line 14. So I look on line 14, which is right here, airport code from airport up, and obviously I don't have that table, just like we had previously determined. But anyways, if it works, it says that it's created successfully, but that doesn't mean that it ran. And that's probably one of the most common things that people miss, is that creates it, that creates the function, but it doesn't actually run it. And so to run it, then you say execute and then the name of the function, and that runs it. So, if I were doing this, I would just paste this in and then paste that in, and you're done. All right. So then once you run that, you should get 50 accounts for each airport in your account list table. All right. Then it says in a prior lab, we blah, 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 blah. So this is where you're going to change our states. Now, the nice thing is this does it for you. But you need to make sure, because like mine, if I do select state province from address, all I have is Utah and CA, so I can change California and be good. If you have something else other than Utah or California, you need to make sure that you have this set up to do the whole name of the state, and then also you need to have an airport for them. And we'll talk about how those match here in a second. So on step G, we do another one where it says update member account. And this is actually where it's the same thing as before. So it's a procedure, you create it, and then you execute it. Now this one doesn't, this one executes it just like the other one. So you'll paste this in, do the execute, and it will run. But what this does is it goes through all your people. So it goes, and we can look at this, and it says for I and member cursor, and our member cursor is, it gets the member ID, the state, and the city from member and contact, and it goes through all of those So for every member in a distinct city and state, it goes through all those and it's going to assign them an account number based on their nearest airport, essentially. And then it's going to consume those, meaning it marks them as being used, because we have 50 per airport, and we could effectively reuse those account numbers. So that's how those are going to work, because it's going to divvy those out, and then we can always reclaim them if we wanted, or we can leave them as consumed. And it'll say who used it, who consumed it, and all that fun stuff. And it goes through. Now, one of the most common things I see is it puts this out. It says you have an error in your airport table inserts. And if you look at this, there's a big clue to kind of help you realize maybe what's going on. And it says when no data found. And what that means is that this select statement right here in this cursor did not pull any data for our airport. So if at any time it doesn't find data, whether it's for our airport or for contact, it's going to give us you have an error in your airport table inserts. And the reason it says that is because it's not matching between them. So just like Marie said in chat, she says, and it is case sensitive. Provo is not the Provo all caps is not the same as Provo with just one capital P. So you want to make sure those match, or there's going to be issues. So, and then once you're done with that, you should get everybody in your database, and they should all have an account number. And our account numbers are going to go from some weird gobbledygook stuff to actually be like SJC000002 and all that kind of fun stuff. And this is how it matches it. So if we look, our address city is San Jose, and our address state is California. That's going to match up with our airport city and in fact, we can look in and see exactly how it does it. It matches it where the airport city is equal to the address city, and the airport state is equal to the address state. So those are the two things you want to make sure that they match on: the city and the state. All right, so that's kind of real quick, I guess, before we move on to the fun last big step, because this is all stuff that we've kind of done before for the most part. You know, we're basically just building tables, inserting some rows into them, then we do a little update statement to fix some data. Stuff we've all done before. Some stuff we've done a few times now, so it should be getting a little bit easier. Does anyone have any questions about the first three steps? All right, well, if you think of one, let me know, and we can come back to it. But in step 4, what we're going to do is we are going to build our, so good question. What does consumed and consumed by mean? So when we consume something, we are essentially using it. So our account numbers, we're going to build 50 account numbers for every airport, right? So for example, Salt Lake City will have 50 accounts. And let's say that the way that our business model works is, you know, we only have one movie store in the area. And let's say we only want to deliver those 50 accounts in the area because we don't want to tax our movie store. We don't want people to come into our movie store and be like, oh, you know, like there's not enough movies like to even rent, you know, all the shelves are empty. So let's say we only build a set number of accounts per area, you know, we just happen to use airports, you know, but you could kind of do whatever you wanted. So we build our number of airports in our accounts, and then as we use those, so then in our script down here, it's going to go through everybody that already has an account, and it's going to take that account number and put it on the member table. So like if we look here, we say update member, set the account number equal to the account number that we just got from our account list table. And once we do that, we're going to consume that account number. So once you finish, when you were to go look in your account list, the account numbers that have been used or assigned to a member will have consumed by set to 1002 and consumed date equal to the date that they were assigned. So imagine if banks did this, and banks very well might do this. They might have all their account numbers like pre-made, and they can go and see like, oh, when did we assign your like account number X, and we could say like, oh, it was assigned in 1990, and who assigned that, and oh, it was assigned by whoever. So does that make sense? When we consume something, we're basically saying we use that account number. It's assigned to somebody, and the reason we do it this way is because let's say that someone's a member for a month and then they cancel their membership. Well, we can reuse that account number if we wanted to. We could reclaim it, or let's say that every 10 years we reclaim those things. So I know like a lot of districts actually do this with student numbers. I don't know if BYU Idaho does or not. I'm not sure. But you can imagine there's a statute that basically you have to keep data for so many years, at least in our public school, and that magic number is 7. So after a student graduates, we have to keep their student number for 7 years. So that means that if we wanted to, we could recycle student numbers. And we don't, because we like to not have to worry about it. So we use a numbering scheme that works for a or 100 years, I believe is what. Yeah, our numbering scheme will work for 100 years. Um, and I chose that because I figure in 100 years it's someone else's problem, right? Um, so I'm not gonna deal with it. But you could track those, right? If your system was so built like ours is, we could track that. We could keep track of who they were consumed by and when they were consumed. And honestly, the realistic answer to a lot of this is we're probably doing it in this lab just for the practice of doing something like this. Okay, good question. Okay, so for step 4, this is where we actually get to do something kind of new and fun. Well, it's definitely new, definitely fun. So we are going to build a table. Just so you know, it's pretty common in ETL stuff. You call it a temp table or a temporary table because it's never something you quite rely on because it's pulling from a CSV. So whatever's in the CSV is what's in the table. And so a lot of times these are temp tables because they're simply used to get the data in the database. They're like a little onboard ramp, essentially. What do they call those? A dock. It's just a way to get the data in, so then we can disperse it into the real tables where the data is going to permanently be stored. So this table, even though we call it a temp table, it's temporary as far as the data within it. The table is going to stay there, but the data in it is just temporary. We're just using it as a holding ground, a loading dock to disperse and transform our data to where it needs to go, which we do in the next labs. It's really cool. So, because I guess just as an example, we pull a bunch of data in here, like account number, first name, last, middle name, all that kind of stuff. And then you'll notice that we have rental item. So checkout date and return date. Well, those are rental columns from the rental table. Rental item type. Oh, that's from rental item. Transaction type, transaction amount, transaction date. Well, those are all from transaction. We have item ID, payment method type. These are all stuff that connect to tables, but they're all different tables. So our transaction upload is kind of going to be this holding pen, because then we're going to take our little bits of data and do things in these other tables to kind of deal with it. All right. And so in Oracle, these are called an external table. And the reason they're called an external table is because the data itself is not stored in the database. It's stored externally in our CSV file. We're doing is building a table to kind of load that CSV data into our table temporarily in memory. And as you can see, I'm using some keywords here. So like in MySQL, this is the engine equals memory flag, which we're not going to go too much into. However, there are some limitations. So like we can't really do more than just create the table. Like all we can really do is have the table name, the data type, and the column names. Now, big important thing here, right? If I was writing this, I would put this in big things with like a big old box around it, exclamation marks. If you're using the latest Fedora image, this whole step right here, this Linux and Oracle virtual directory setups, has been done for you. So you don't even need to open it, right? Don't even open that. See, and it says open these additional instructions only if you are not using the instructor provided Linux image. So that should already be done for you. And that's why it's already there. So yeah, should be all done for you. Okay. These ones too. Those should all be done for you. So then all we need to do, and we can test this, right? So let's, and somewhere here, it tells you where to write this. Oh, right here. Okay, so this is a little pro tip. So if we open this in a new tab here, this will give you a really nice starting point to how we're going to do this. And I'm going to help you a little bit too here. But basically, we have to tell it where we're getting our files per se. And so because this table is a little different because we have to pull from a CSV file. So if we were going to build an external table, we would do this. And you can notice that, so we have our normal create table, we have our column, but then we have this new stuff. It says organizational external, and then we have this stuff here that basically tells it where we're getting it. And so this is what we're going to be doing a lot of. And it kind of builds on each other. So because this one here actually produces this error, and so you have to get all the way down to right here. So this is actually the right one that we're looking for. So, and I just kind of want to talk about what all these are real quick. So organization external is basically us telling the computer, hey, this is going to be an external table, meaning we're loading from somewhere else. And then as part of that, then we put a parenthesis because we're going to define some parameters here. So we say the type is an Oracle loader. We don't really need to know what that is, nor do we care. It just is telling the computer that we're using the default data loader. And then we have our default directory. Now, in this case, our directory is called upload. So you would put upload here where it says download. And then we have access parameters. And then we say the records are delimited by a new line. And that's just like ours is. And that means that every new row, every record or every row is going to be separated by a return. So if we were to pull open that CSV, we'd look and it would have those all separated, each row on its own line. That's all that means. And then we see the character set is ASCII. That should be fine. So then our bad file, and you would put upload here. So everywhere it says download, you're going to put upload. And then we build some files. Because let's say we go to run this, we go to query this file, this table, and let's say that someone did put some bad data in there. Let's say we're separated by a comma like we are in ours, but let's say that they put a comma in their name. Well, that row would then throw an error. And so what we do is we want to be able to know when something goes wrong, right? So we create 3 files. There's a bad file, which means bad records. There's a discard file, which means that records were discarded. And then a log file that just tells us basically everything that happened. So we replace, so this is the name of our directory. And just so you know, our directory upload is predefined to be this right here. So when I say upload, basically we just defined it in Oracle to say, oh, this is the file path. So you're going here to this upload. So if we ever have any issues, it's going to create those files inside that directory. So this is going to be upload, all caps, and then we can give this a file. So I would say something like transaction.bad, transaction.dis, and transaction.log. Yep. So Marie asked, no permissions are necessary. And no permissions are necessary. It should all be set up. If you have any issues, let me know because we can fix those permissions, but they should all be, if you're using our Fedora image, they should all be set up for you. So you have your different log files that you create. And so in this case, they have their directory called download. Ours is called upload, which is just the opposite. And then their table's character. So you could just put like transaction or transaction upload for those. Then we say fields are terminated by a character. And this is what is the delimiter. What are we using to separate columns or fields? And in this case, like we talked about, it's a comma. That's why it's a CSV, a comma separated values. So we use a comma to separate it. Now, things can optionally be enclosed by a single quote. So if we did have a first name, last name separated by a comma in a single field, let's say that our column is called full name, we could put a single quote around those and it would know that that column needs to just be imported and it doesn't separate those fields. And then we say that if the field is missing, we're going to insert null. And then lastly, but the most important, is our location. This is where we just say our file. So we would change this to transaction upload, transaction underscore upload to.csv. And then our reject limit is unlimited, meaning that if it has to reject all of them, it's unlimited, because you can make it so, let's say that we were doing like on my imports for my job, if more than, because like let's say I'm doing an import with 5,000 students and each student has a record. Well, I can say if more than 100 fail, just stop because something's wrong. Something like that. But in this case, we're saying the reject limit is unlimited. So just go all the way through it no matter what. And there's that. If you get an error like this, that means that there is a issue with this right here in any one of those. So download needs to be changed to upload or something like that. But it'll say directory object upload not found or whatever. And so then you can do that. And then, so that's all you need to know is basically that step, task 2, implementing an external CSV. All right, so you would just build out the columns, add that little chunk down at the bottom. Oh, and okay, so another fun thing is they actually have this here for you. Nope, so it's just one table. It's just one table transaction upload. So if I were going to do it, I would say, just open up a new one of these. I would say create table transaction upload, just like normal, right? And then I would have column, data type, blah, 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 right? You'd fill out that stuff. Just like we have here, right? So this is their character table. Ours is just going to be transaction upload. we have all of our columns and data types just like we normally do, but we don't have to worry about primary keys and all that because our data is not actually being stored here and we can't do that. So we build out our columns. Then we need to do all this stuff to basically say that it's external. Now, we talked about what it all meant. The nice thing is there's this nice little thing here that helps us know what that would be. So this is exactly how it should look, which is very convenient. So I would just paste something like this in here and add a semicolon. So that's what it would look like for our transaction upload stuff. Right? And so all you need to do is add your columns and your data types, and you're good. And just one of these. We only need one transaction upload table. So you just need one of these. But these 3 files are what will be created if something goes wrong. So if everything goes right, you should never see any of these files except for this log file. And I guess just to, let's try it real quick. So let's go into data. And this is what you should get at the end. You should get your 11,520 rows. Now, if I go look in here, like we talked about, if everything goes right, the only file you should see is your transaction upload log. And we can look in here and it tells us what it did. So it says that, this time, this is all the various columns, and then it tells us what it did here. So hits was 3, blah, blah, blah. And nothing went wrong, so we're good. Basically, it just says how we imported it. If something were to break, we would then get transaction upload.dis or transaction upload.bad. Yep, so now we can select from the table. So now I can do select distinct last name from transaction upload. And there we have our transaction upload stuff. And the nice thing is we're doing this right from a CSV file, right? So all the data that we just pulled up is actually right there in transaction upload. And sorry, I think I keep saying transaction upload 2. It's transaction upload, not transaction upload 2. Because here's our first name, last name, 3-day rental, all that kind of stuff. So this is the file you should be looking at. And it's doing it a little weird. Let's actually try to reopen that. And we can go into format and we can say text quote is a single quote, just like we did in our other thing, right? Our delimiter is a comma, optionally enclosed with a single quote, and then we can hit OK. And now we should look a little better. And there we go. And there is our data that we just pulled, right? So then I can do stuff like, select everything from transaction upload where, and let's see, what would this row be? Transaction amount. And let's say is greater than 318. Let's see if we had anyone greater than 318. Nope, none greater than 318. But we can, let's say, select everything where last name is equal to Potter. And then we have all of the Potter family's transactions. And we can see every dollar they spent and what movie they rented for how many days and what credit card they used. Right. So good questions. Does anyone have any questions, curiosities about that? And this is kind of just phase one. So this is kind of like the step one of this whole process, because we're just getting it here, because then we can do other things. Like you just saw me just do a select. We're going to actually take this data and insert it into our tables, backdate everything. So Harry Potter is going to go from having 2 rentals to having, however, well, let's just look. And first name is equal to Harry. He's going to go from having 3 to having 768 plus 3, or however many he had. I can't remember if it was 2 or 3. So the airport info, basically, the airport info is just how we're going to separate geographic areas. So that's however they decided to do it. And I know, like, for a good example, the church might use temples. Like, for example, think about a mission, right? So our database is going to use airports, but the church for missions, like, they might use mission offices, as kind of like their deterministic factor for whatever, or basically it's just a way that we're going to isolate, like, okay, this account is SLC0, because then we could say, select last name, first name from transaction upload, where, let's see, I can't even remember the name of that column now. Account number, I should have known that. And there, so now we have all of our, we selected everything. So if we wanted to see all the transactions that happened in our Salt Lake City branch, boom, there we go. So you could use states, but let's say that this company, this video store company, doesn't do branches by state. Let's say they have one manager that manages, or one executive that manages, Wyoming, Utah, Idaho, and Colorado, or whatever. And however they decide to lump that together is up to them. But in this case, we've decided to use airports. So it's just a regional thing. Now we could add states, but we already have what state the household's in, and so the account numbers. And I can't tell you why, but yeah, they just decided that they're going to lump their account numbers together by airports. Basically by city, essentially, because it's really what it comes down to. So a unique, what is the difference between unique and primary or foreign? So, and they're almost kind of different things. So a unique key or constraint is how we, and I guess they're kind of the same. So a primary key has to be unique. So for example, in a like contact, we have contact ID is the primary key. And the primary key is a value that distinctly identifies a single row. So if I say select everything from contact where contact ID is equal to 1001, I know that because I'm using the primary key, if I just put one value here, I will only get one row because it uniquely identifies that one person. It's unique to them or unique to whatever data is in that table. So that's a primary key. Now, where this gets a little confusing is because a primary key automatically creates a unique constraint on that column. So a unique constraint or a unique key is something that means that has to be unique. So, for example, in what's a good example? If I were to put a unique constraint, so let's do select distinct last name from contact. If I were to put a unique constraint on last name and last name only, I could only have one version of the last name in there, which if I select distinct, that's all it would let me do. So that means that I could only have one Potter, one Smith, one Royal, one Gretzel, one Moss. And a good example of that is if we were going to have a table of all the states in the United States, we would put a unique constraint on the state name because we don't want two Wyomings. Does that make sense with the unique thing? Unique means that there's only one. It's rare, it's only one. And when we create a primary key, it automatically creates a unique constraint on that column because it has to uniquely identify each row. When we create a unique constraint on another one, then it will do it too. Now, I keep saying unique key or unique constraint. The difference is when we say key, because a constraint means that we can't insert without breaking that constraint, right? We've seen that before where we try to do something and it says, oh, this violates this constraint or whatever. That's what a unique constraint does. Well, a key, anytime you have a key, it's just like we talked about, if you remember quite a while ago, we talked about, filing cabinets at the libraries way back in the day before computers. They had those filing cabinets and they had indexes, right? And so when we create a unique index on a column, what we're doing is we're telling the computer that that's going to be unique. And so what it does is when it finds it, it knows it's the only row. And in general, when we create indexes, we are we're building rules to make it so the computer can be faster because it can do logic. So, for example, if there was a unique key on last name per se, let's go back to our previous one. Let's say I do select everything from contact where last name equals Potter, right? If I'm the computer, or let's say Smith, this is a better example. Or no, let's pick something different. Let's say Sweeney. No, Royal. Sorry, I'm thinking backwards. So I create a unique index on last name, and I tell the computer select everything from last name from contact where last name is equal to Royal. Right? Well, it's going to start going row by row, and it's going to say, okay, row 1, does last name equal Royal? Yes, it does. Well, if there weren't a unique index on last name, it would have to check every other row to make sure that there aren't more. With a unique index, it found Royal, it goes, oh, I know that this is unique, so there can only be one, so I'm done, and it's super fast, right? Now, that's a pretty basic example, and that's how indexes work in general. So, I mean, there's all sorts of different indexes, as you've seen. You can just create indexes on stuff. But when we create a unique key on something like that, that's what we're allowing the computer to do, is we're allowing it to have these rules so it can be faster. So when you see that we're building indexes are really a performance thing. You can do all this without indexes, but you cannot do all this without primary and foreign keys, because that brings us to the last one that we haven't talked about, which is our foreign key. So primary key, like contact, so if we select everything from contact, and let's make this bigger so we can see a little bit better, huh? So if we select everything from contact, we know that contact ID is our primary key. And we know that it uniquely identifies each row in this table. Well, then if we look up telephone, right? If we look up telephone, we need a way to connect, this telephone number to a person or a contact. So we have our contact ID here, and we have our contact ID here. This contact ID is the primary key for contact because it uniquely identifies each row. Now down here, this is the foreign key because does contact ID belong in the telephone table? No, because it doesn't, respectively, it doesn't really have much to do with the telephone. But what it does, it's that one bit of information that connects it to something else. That's how I like to remember it. Foreign. It doesn't belong here, but it does because it's the only way that we get to the outside world. So that's how we match a contact to a telephone, by a primary key and a foreign key relationship. Because then we can look and say, okay, Jeffrey Ward Clinton, what's your telephone number? Well, your contact ID is 1008. So we come here, contact ID is 1008. Your telephone is 801-423-1234. Now, effectively, he could have multiple telephone numbers in here, right? Because in our telephone table, we have home and work. So he could also have his work telephone, and in which case he would have two records here, one for each one. Does that make sense? Does that help at all?
Yes, it does.
Perfect. And I guess just to bring this full circle, a good example of another unique or a natural key, since you're going to be doing natural keys this week in the lab, a good natural key is, let's say we only want people to have one home phone number and one work phone number. You have to choose, right? You can't have three
Awesome.
you can't have three home phone numbers and that sort of thing, right? Let's just say that's something that we as programmers want to implement in our software. We could build a
All right. Well, that sounds good. Thanks for, giving me an update. And
we
Oh,
could
sorry.
build a
just know that
we could build a natural key on contact ID, telephone type, and area code and telephone number. Or we could leave off area code, telephone number. If we wanted to make sure they only had one of each type, we would build it on contact ID and telephone type. And that would mean that the person could only have one home phone number and one work phone number. Yeah, and so a unique key, when you build a unique key, it's a unique, it's also a constraint. I use those, yeah, interchangeably because it's also a constraint, also a key. And let's see, let's go back up to where that was. Yep. So when we build it, we're going to build these over multiple columns. So it's not just one. We're actually going to build that key across multiple columns, like right here. We're going to create a unique key index for the airport table on 4 columns. Let me see if I can find you guys a quick example of that. So if I wanted to build this key or this index on multiple columns, so for like airport, I would do this. So I have create a unique index on, and then I give it a name on airport. And then in parentheses, I specify all the columns separated by commas that I want to be a part of that index. So that means the combination of those must be unique. Does that make sense to everybody? Good questions. All right. Does anyone else have any other questions about the lab? We still have some time, and I've been at work, so if no one else has any questions about the lab, we can dive into a little custom extracurricular thing if you guys would like. All right, going once, going twice. Oh yeah, and if you need to go, no worries. Like I said, this is just extra, so you can always watch it later. Um, so yeah, if you have something more important, by all means, go. As the old guy says in Rapunzel, or Tangled, go live your dream. One of my favorite movies of all time. I don't know if I'd say all time, but it's pretty good. All right. So I had been like just painstakingly trying to think of of a good like database project, because what I've wanted to show you guys is, especially after the meeting we had a little while ago, I wanted to build something that would have um, show you like what you can do with the database as far as like how it works, like when you actually build like a front end or an application, um, and also the database. But I wanted it to be something that was, half meaningful in a way, but also simple enough that it wasn't ginormous. So what I decided to do was, I thought, well, it might be kind of fun to have a place where we could have all of the labs and all the steps built into a database, and then have a way for you as students to where if you find, like a little tip, like, oh, watch out for this or whatever, you could just put a little note there and have it all kind of lumped together. So if you were a student, you could go in and say, okay, I'm on lab 8, step whatever, and you could see all the student tips that have been submitted for previous semesters for who knows how long. And so that's what I started to build. And I didn't want to get too far because I kind of wanted you guys to be a part of it. So anyways, here it is. I have the repository on GitHub. It will be available here. And like I said, this is all extra. So please do not sacrifice other school or this class. Don't sacrifice your lab to do this, because it is just extra. If anything, let it just, get you excited about it all. So anyways, but the repository is here. I'm going to continually add to it. So by the end, it'll get there. But so for now, what I want to do is just kind of talk about a little bit, because I kind of built the foundation of it all. So also on my GitHub is a repository called Flask Base right here. And this Flask base, what it does is it and it's not LT, not admin LT. Let's fix that. So this Flask is a web application kind of what do they call it? Framework. And it uses Python, which is really nice because Python is a nice and easy programming language. And it's really modular. It's got a lot of plugins, which means that you don't have to do a lot of like manual boilerplate labor. You can just do a lot of stuff. So anyways, what I'm going to do is I'm going to actually kind of walk you through the actual process of if you wanted to start working on this. So I'm going to open up a terminal right here. And so just so you know, I worked on this a little bit somewhere else. So I'm going to real quickly delete my old file. And now I'm nervous, but we're going to trust it. Okay, so I'm in the directory where I want to put my files here. So what I do is I go to my Git repository, and then I can say clone or download, and I'm going to copy this link here. And I'm going to just come here and I'm going to say git clone. Now your mileage may vary based on Windows and all that kind of stuff. If you're on Windows, I would highly recommend just use the Windows subsystem layer for Linux, WSL. Look it up. If you're on Mac, I believe all you need is Xcode tools installed. You have Git. But anyways, I'm going to say git clone and then the URL. And then it clones it. So now if I look what's in here, I now have, oh, and that was the wrong one. That was Flask base. We need to go back to my 225. So Flask base is an empty Flask one. If you ever want it, it's there. It's really nice. It works really well. This one has our stuff kind of started. So it's kind of going to be our foundation for our CIT225 tip. So I'm going to take this. We're going to do the same thing. We're going to say git clone, name of the repository, and now I should have this CIT225 tips right here. Then if I come in here, now I have all my files that are there, and we're going to talk about Git along the way because if you're not using Git, it's amazing and you'll want to, and you'll see why here in a minute. So real quick, let's look at some of what's going on here. So real quick, I'm going to open up this folder in a text editor here. All right, here I am. And so now what I want to do is I want to show you the foundation of all this. So this is our database, right? So I have the script here, just like we've been using, that will create all of our stuff here for us. So, you know, we have account type, term, user account. We have a lab table. We have a lab step table. We have a post lab, which is where you'll actually like post your tip. And then we insert some data. So we have some different account types. We have administrator, student, teaching assistant, and alumni. Then we have some terms, one term, Winter 2020, and all that kind of stuff. Then we have some labs. So then I built labs 1 through 14. And then I also built general. And then I use a little trick. Just so you guys remember in lab 7, how we did that cross join with the union select statement for the yes and the no and the 1, 2, 3. Well, here's another real life scenario. So I thought, well, I don't want to have to manually write all these rows. So let's just assume that every lab has at least 4 steps. So then I just said select 1 as step, union, select 2 as step, 3 and 4, and called that fake table step. And I cross join that with every lab, and that builds steps 1 through 4 for every lab. Nice and simple. So I guess I forgot to mention that this is using PostgreSQL, the database. And we talked a little bit about that last time, but you have the scripts there. So if I come over here and let me refresh this, so I run my script and it creates all this stuff. So I can come in here and I can say select everything from lab. Oh, and that's the wrong folder there. Let's try again. So now if I select everything from lab, I'll get my lab. Now you'll notice that I don't have any description or instructions in there yet because, we're just going to try to get base functionality. Then we'll make it pretty. So I have my database for the most part set up, which, I didn't want to cover that too much because I didn't want to confuse you with Postgres while you're trying to learn and do Oracle stuff. But I also wanted to show you because the fundamental ideas between them all work the same. So just like we just got done talking about, we have lab ID as the primary key for lab, and then we have lab step that has lab ID, so then we can see every lab and the different steps. So lab ID 1 has steps 1, 3, 4, 2, they're out of order, but it's all the same. And then we can, in dbeaver, we can actually, it's a foreign key because it has this little icon next to it because it knows that, oh, I can just take you there to lab 2. So anyways, that's our database and the whole idea kind of behind it. And I don't want to get too crazy. So I just real quick wanted to show you a little bit how Flask works, just so we get there. So Flask, what we're going to be doing is we're going to be using Python. So this is kind of where we can define our stuff, and we're going to connect our database. I'm not going to do it all right here because, like I said, I don't want to confuse you. But by the next class, what we should have is I should have the database all connected, and we'll talk a lot about it. I'm going to use what's called SQL Alchemy, which is a Python-ish way of doing database queries and stuff. We can always write them manually, but it makes it nice because then we have our objects all there. But basically what we're going to do is we're going to build a web application that will let you create an account. You'll be able to create an account, sign up with your email, and then you'll be able to go through all the different labs and post. And even without an account, you'll be able to go look it up. But if you want to post, you'll be able to make an account and do that. Now, just some quick features I wanted to show you. Some different design things that I came across. For example, a term. I thought, well, do I want to, track which term kids are in? And I thought, well, it might be kind of fun because then you can see when they took the class. And, let's say 10 years from now, you come back to this website and, you could go and, say like, oh, that student, I remember them. And yeah, sure enough, they're in the same term that I took the class and all that kind of stuff. But now if a student, one of the things that I had to think about was, well, if a student fails the class and retakes it, how am I going to manage that? And can a student be in multiple terms? And then I thought, I don't know, because you'll look down here at user account, we have term ID here. And so the term ID is just one-to-one, meaning that a user can only be in one term at a time, and we don't track it historically. So essentially I just made it so I'm not going to, because the odds of someone, and this is kind of where that design thing comes in, because I'm assuming that for the most part, most people aren't going to fail my course and retake it. And if they do, they can always just, change the term. But I didn't care to track it because the odds of it happening are low. So all that workload wasn't worth it. The juice wasn't worth the squeeze per se. And that kind of stuff. So anyways, I don't want to take up too much of your time, but that repository is there. if you want to take a look. How many computer languages do I know and use? Many. And you'll be surprised. I remember like thinking, wow, like I'm trying to learn one, and but the thing is once you learn one, and the more you start dabbling, you'll learn one, then you'll learn two, and then it's just a matter of like doing it a couple of times and Googling a few things, and you can pretty much do them all. As far as how many I know, well, I'll just start naming some off because I'm not going to count SQL. I guess for databases, I know MySQL, I know Oracle, I know Microsoft SQL Server, and I know Postgres. So those are all pretty much the same, though. Like I said, it sounds pretty impressive, but they're all pretty much the same. As far as programming languages, I know Python, uh, JavaScript, C++, Dart, Kotlin, Java, and Swift. I think that's just about it. And like I said, again, it sounds complicated, but it's not too much. And every time I go to write in one of those languages, Python's one of those that really hangs for me around. But for the most part, on a lot of those other ones, I have to like kind of get into the frame of mind and get used to it again, if that makes sense. But I use Python the most as far as a programming language. Um, I use a lot of JavaScript. And then you start like splitting hairs. Like, is JavaScript and Angular? Do you count those as the same? I do. Um, I use Python, JavaScript, um, but most of what I do is um, Python, SQL, JavaScript, HTML, CSS. That's kind of like the majority of my stuff. So, anyways, so yeah, we'll keep working on this little side project, hopefully along the way. Um, excuse me. And then what'll be nice is then we'll have kind of another little thing. And the other thing is I tried to do this one so because what's kind of funny is our database is uh, our movie database is getting dated in the fact that you know it's hard to remember even what that was like, and there's probably upcoming students who may not even remember what that was like. So I kind of wanted to also introduce something else because also the school is planning on switching to Postgres as their learning. So everything we're doing now will be in Postgres. And so I thought, well, I'm going to build this in Postgres and have it as like another extra example. So that way, if you wanted to just see it from another perspective, another point of view, it would be there. Right now, I'm not quite sure when it officially is. I know it's being tested. Um, and I know I've talked about this before, but the main reason why they're switching to Postgres is because you wouldn't have to install the whole virtual machine. Um, you could have a virtual machine, but just like we did last week, I believe, um, where I built this server for you. Um, we did this, and I installed MySQL and Apache on here. But you could essentially have this, which is 2 gigs. It's like very small considering the other one's 14 gigs. And we can just install PostgreSQL as simple as this. Sudo apt install PostgreSQL, and it's installing PostgreSQL because Oracle is extremely difficult to maintain and install. I mean, it's just a monster. And so that's why we do the virtual machine, is because that way it's all set up for you. Versus something like this, we can have a guide or a script. We can script it just to do it for you. So, I issued one command, and now I can just I'm in a database just like that. Just a couple of commands, which we can script. And those last couple of commands were actually me just getting in. So, we can script it, or we can just say here, download this 2 gig file, open it in VirtualBox, and run this script, and you're all set up. And so that's the main reason they're switching. And why not MySQL? A lot of people might ask, because MySQL would be just as simple as this. The main reason why not MySQL, I believe, is because MySQL doesn't have near the feature set of Oracle, which is why we're using Oracle in class. And Postgres is an Oracle equivalent. It has all of the bells and whistles of something like Oracle or Microsoft SQL Server would, but the biggest thing is it's open source. So there's also the possibility that instead of even having a virtual machine on your computer, they could host the machine for you, and you could just connect to it like you do for your computer science classes if you're in one of those that do that. So because it's open source and there's no licensing, because databases can be very expensive, very, very expensive. But when you're using open source software, it is free. All right. Any other questions before we call it a day? Okay, so someone said, how do I find out the specialty name that a constraint should have if you aren't setting it up at the beginning? Specialty name. I'm not quite sure. Oh, like the name of the constraint?
1,120 encoder steps per revolution.
So yeah, if you want to know the constraint name, you can actually query the constraint out of the data dictionary. The best actually is in Oracle Apex to look it up there, or in I don't have it up right now, but SQL Developer, if you wanted to look in there, it'd be similar. You could actually come in here and pull open the constraints. So like right here, I go here and can see the constraints on that column.
So the question, so it means you in lab 8, last lab, the last question asked us to change the not null constraint. And I couldn't figure out what name to call it, because no matter what I put in there, it didn't let me do that not null.
Gotcha.
Does that make sense?
Yeah.
Because when I looked it up, it said, not null, blah, 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 1, 2, 3, 4, 5, 6, 7. But there was a spot in the middle between 6 and 7 that was empty, that was the one we were trying to make not null, right? And so I tried not null 8, and it didn't let me do that. But there wasn't another not null 8, so I didn't understand how I was supposed to guess that name.
Yeah, send me, if it's giving you an error, send me what it's sending you, because yeah, it's kind of weird.
I can do that. Thanks.
Yep. And then can you please explain the difference between core, access layer, and view? In what context? I'm guessing that you're meaning something along the lines of like model, view, and controller. Like in the Teradata. I'm not sure if I remember. I don't think I've ever even heard of Teradata, actually. I'm looking it up real quick. My guess, storage. Oh, okay. Yeah. So basically, let me make sure I don't tell you wrong here. Okay, yeah, so we're actually going to do a little bit of this. So the access layer, if this is the same thing, is we're actually going to be doing a little bit of this inside of our inside of our little app that we're going to build. We're going to build our own data access layer per se. Because like it says, for example, instead of using commands such as insert, delete, and update to access specific table in a database class, a class and a few stored procedures could be created in the database. So essentially what it is the access layer is, instead of actually running SQL, it's taking, like, so for example, it's going, well, here, I have a really good example right here. In another project I'm working on, documents development. Well, I know I have it here in my repository. Yeah, so views are a good way of locking stuff, especially like if you're doing analytics. Views are nice because you don't have access to the actual, you can see the data, but you can't change the data. So views are often used as like, oh, here's a view into the data. And you can see things, but you can't change them. And you can also restrict what's there. But I guess as a example of what they're talking about as a layer, a data layer. So I have a database that keeps track of cow stuff, agriculture, herds, and all that. So here are my tables. So I have stuff like an animal, and a farm, and a location, and a pen, and that kind of stuff. Well, if I go into my front end, my application, I have a data layer defined right here. And you'll notice that this is my objects. This is Python. So what they do to make it a little, not necessarily faster, but I guess more, it allows you to build programs that are dynamic. Because believe it or not, this actually is generated from my database. I didn't type any of this code. I actually built the database, and then I said, hey, Python, build objects for all the stuff in my database. And it says, okay, I'll do it. And so this is the result. And so we have an animal class, and then I could build, there's built-in procedures off this that's inside base that will do various things like delete animal, or insert an animal, or update an animal gender, per se, stuff like that. So from what I can understand, and I haven't lived very much in that software, but this is basically the access layer, what they call it, the data access layer. Because basically it's just like a programmy interface to our database, an object-oriented program database layer. All right, any other questions? All righty, well, it looks like our brains are tired. So anyways, thank you guys all for coming. Thanks for all your good questions. Hopefully these extra conversations help and don't add to the confusion. If you are confused, don't worry about it. They are extra. But often, sometimes exploring them, I feel like does add a little, it helps you fill out that third dimension, because you might see it two-dimensionally, but seeing it in the third might help just a little bit. And that's kind of my hope, and it's fun. So anyways, thank you all for coming. If you have any questions, like always, feel free to reach out to me, ask on Slack, and someone will get to it, hopefully. If it goes by and you don't get a response, please shoot me a direct message, because a lot of times my daughter gets a hold of my phone and I just miss the notifications. Don't take it personally. It might just be, it might be as simple as my daughter grabbed my phone and dismissed the notification. So yeah, everyone have a good evening and the good rest of the week, and yeah, be safe out there.